So we have a system of linear equations here, and as you can tell, we are going to solve them, but we don't solve it in the usual way that we've been solving them, that is substitution, elimination, or graphically. What we do is we use this method known as Cramer's rule. Now with Cramer's rule, we make use of matrices. Okay, so first thing we do is we can write the system of linear equations in matrix form. And the first matrix we have is a matrix of coefficients. So you know what coefficients are? These are the numbers that are in front of your variables, and you put them in a matrix. And the column is for a specific variable. So if in the first row, first column, you have the coefficient of x, in the second row, first column, it should also be the coefficient of x. So just be careful not to mix those up. Or if you get a question like this, 3x minus 4y is equal to 6, and then I have minus 3y plus 5y is equal to minus 1. Those are the same thing essentially, but rewrite it this way so that I have all my x's here, all my y's there, and then in that manner. Okay, so we make our coefficient matrix. Now our coefficient matrix is a matrix filled with the coefficients. So the first one is 3. So I will put my x coefficients in the first column and my y coefficients in the second column. So the second x coefficient I have is 5. And then here the first x coefficient I have is minus 4. So it is minus 4 and not just 4. The sign in front of it matters. I don't write plus 3 over there because writing plus 3 is redundant or it's superfluous. It doesn't really matter, okay? It doesn't change anything, but leaving out the negative definitely changes what I have. And then over here I have minus 3, which is the one I get over there. This is a 2 by 2 matrix. As you know, it has 1, 2 rows and then 1, 2 columns. So 2 rows and 2 columns. Then I have my coefficient, I have my variable matrix rather. So here my variable, first one is x because that is the first column, and then I have y like that. Okay, so just put them in the order that you have them. You can see that here I have a 2 by 1 matrix, 2 rows and 1 column. So I can see if I were to multiply these, it is possible to multiply them because in my rectangle these two numbers are the same, and the matrix I would get at the end is a 2 by 1. So when I would multiply these, I would get this matrix here, 6 minus 1, because I would say 3 times x plus minus 4 times y gives me 6. That was the first row, first column. It should be first row, first column. And then I would say second row with the column, so it's 5 times x plus minus 3 times y gives me that. So this was second row, first column. It goes second row in the first column, and that is why it is equal to. And you can see that that is just this system of equations that I have over here. Now using Cramer's rule to solve this is very simple, because all we do is we work with determinants. Now depending on the number of variables that you have, you will have to come up with a matrix for each of the variables. Now this coefficient matrix here, I'm going to call it A. So I put A is equal to my matrix here. So this is 3 minus 4, 5, and then minus 3. Okay, so that is my first matrix. I hope you can see it. Then what I do is the column that represents x, I am going to change it and replace the values with the solution matrix. So these are the solution, the 6 and the minus 1. What I will do, you can see it's a column matrix. I will replace this, this 3 and 5 with the elements in the solution matrix 6 and 1. And I will call this AX. I'll call the matrix AX because I'm replacing the coefficients of the X values. So it's AX will look like this. So instead of 3 and 5, I will have 6 and minus 1. So I have 6 minus 1, and then everything else stays the same. The values of in the second column should stay as they are. So I have minus 4 here, and then I have minus 3. Okay, then what I do is I form another matrix for y, where I replace this column, which represents the coefficients of y, with the values in the solution matrix. So I will call this matrix AY. So I'm calling them A because I derived these matrices from this matrix A. And here, just so that I don't get confused on what I changed the coefficients of x, and this one I changed the coefficients of y. And what I get is this: the x values should stay the same, so I don't change or I don't substitute or swap the x column and the y column at the same time. I'm always only replacing one column at a time. So with bigger matrices you will be able to see that better, but here I only change the y of A. So this one should stay the same, so it's 3 and 5. And then over here, instead of minus 4 and minus 3, I replace it with 6 and minus 1. Okay, so that is the first part of Cramer's rule. I have my system of linear equations that I have over there, and I need to find out what is x and what is y. I can represent them in a matrix form like this. This is my matrix A, my coefficient matrix, where I take the coefficients of x, I put them in a column, the coefficients of y with their signs, I put them in a column, and then my variable matrix. Then I know that this multiplication of these matrices is possible because they are compatible, and my resulting matrix, or my solution matrix, is a 2 by 1 matrix. So here I didn't write it, but it is a 2 by 1 matrix. Okay, so to apply Cramer's rule, the thing I need to do is I write down this coefficient matrix. There it is, my coefficients of x. The x values should all be in one column. The y coefficients will also be in one column. Then for ax, this means I'm changing a slightly, but how am I changing that? I take the column with x values and I replace them with the values from the solution matrix. So here there was supposed to be 3, so you can see over there, but I have 6. Supposed to have 5 here, but I have 1, so I've just replaced them. The y stays the same because I replace one variable column at a time. And then I do the same thing with the y matrix. So I start with A, so I'm not replacing the x column, it stays the same, so it's 3, 3, 5, and 5. And then the y column, that is what I replace. You can see there, instead of minus 4, I have 6. Instead of minus 3, I have minus 1. Okay, now that you have those matrices, the next step is very simple. Right, so Cramer's rule basically says the formula to work out what the variable x is this. So this x will be equal to the determinant of ax divided by the determinant of a, and same thing, y will be equal to the determinant of ay divided by the determinant of the original coefficient matrix A. So we know how to work out these individual determinants. They are not difficult to do. We know that with a 2 by 2 matrix, the determinant is very simple. You find the product on the leading diagonal, and then from that you subtract the product of the minor diagonal. So let's work that out. So determinant of A, can work this out. So it's 3 times minus 3, which is minus 9, and from that we subtract 5 times minus 4, which is minus 20. When we work this out, our answer should be equal to 11. Okay, so in the same way, we can work out the determinant of matrix A sub x. That means we've interchanged the x coefficients with our solution, and this again is the product on the major diagonal. Remember, major is top left to bottom right. So this is minus 18 minus negative 1 times negative 4 is positive 4. So I get minus 4, and this should be equal to negative 22. Okay, similarly, the determinant of AY, this is equal to 3 times negative 1, which is negative 3, and then I have to subtract 5 times 6, which is 30. Okay, so I have negative 3 minus 30, and then over here what I get is equal to negative 33. Okay, so that is simple to do. We know what the determinant of each of these are. Now we just need to apply Cramer's rule to work out what each of those are. Okay, so over here, I will just continue over there. I'll make some space later on if I need to. Okay, so we say the value of x is equal to the determinant of a sub x, which we got over here. We said it is minus 22, and the determinant of a is 11. So we just say this is negative 22 over 11. Let me just go ahead and make some space. Okay, so it's negative 22 over 11. That is a simple calculation which you should be able to do, and this is equal to negative 2. So that means x is equal to negative 2. Now these solutions that we get, we should be able to substitute them into the original equations and then see if they do satisfy the equations. Okay, and then if you remember the formula for y by Cramer's rule is this: y is equal to the determinant of ay over the determinant of a. So brackets, some books have brackets, some don't, but that's fine. So the determinant of ay, when we worked it out, is over here. It is minus 33. So this is equal to minus 33. And then the determinant of a, we got 11. If you remember, there it is. So when I work this out, minus 33 divided by 11, my answer is equal to minus 3. So I get y is equal to minus 3. Now what we can do and what we should do is always check if our solutions are correct. So don't just assume you did everything perfectly. Just very quickly on your calculator, go ahead and check if your solutions are correct. So I will do that just now. So I have my values of x and y that I got. I said x is minus 2, y is minus 3. Now remember, the original equation was this: 3x minus 4y. This should be equal to positive 6. So I checked that on my calculator, or just over here. So it's 3 times x, this is minus 2, minus 4 times minus 3, 3 times minus 2, this is minus 6, and then minus 4 times minus 3, this is positive 12. And then I get my answer is equal to 6, which is what I was supposed to get. So my values for x is equal to minus 2 and y is equal to minus 3 do satisfy the first equation. But we don't need to just stop there. We should test them in both equations. The second equation said 5x minus, rather, not plus, 5x minus 3y is equal to minus 1. So when we substitute x and y there, our answer should be equal to minus 1. So let's go ahead and try it. So it's 5 times minus 2 minus 3 times minus 3, and then our answer should be equal to minus 1. If my solutions for x satisfy both equations, then those are the true solutions. So 5 times minus 2, this is minus 10, and then minus 3 times minus 3, this is positive 9, minus 10 plus 1, this is actually equal to negative 1, which is what we wanted to check over there. So my solutions, x is equal to minus 2 and x is equal to 3, are indeed correct. Okay, and I've used Cramer's rule to work out a simultaneous equation. Okay, on to the next question. It says the sum of two numbers is 45 and their difference is 15. What are the two numbers? Now this is a word problem which I'm sure you can come up with an equation for and easily solve. You'd notice that it is a simultaneous equation and solving this one should not be difficult. Okay, so first thing we do, let's come up with a system of linear equations. Now remember, we need to solve this using Cramer's rule. Alright, so with Cramer's rule, we just need a system of linear equations. So we have two numbers whose sum is 45, so we can call the numbers x and y. So I have x plus y is equal to 45, because sum means when I add the numbers sum, you are adding numbers together. Okay, and then it says that their difference is 45. With difference, we are subtracting. So difference, x minus y, is equal to 15. Now again, you can always solve this with substitution, elimination, graphically. But this question, we are focusing on Cramer's rule. So you can always try it using elimination and see how the answer is going to be the same. So with Cramer's rule, if you remember, first thing we need to do is form our matrix A, which is our coefficient matrix. So we take the coefficients of x, which is 1 and 1, and then the coefficients of y, which is 1 and minus 1. Okay, then we need this matrix over here, AX. This matrix here, remember how we get it? Our column that represents the x coefficient, so the coefficients of x, which is 1 and 1, we would replace them with these numbers that we have over here, 45 and 15. So I have a matrix that looks like this, 45 and 15, and then this column that represents the y coefficients stay exactly as they are. So I have 1 and minus 1. Then there is the matrix where I replace the column of the y coefficients. So we call it AY just for convenience. The name doesn't actually matter. Okay, so the x column stays the same. The only thing that changes is the y column. So this is 45 and 15. Okay, so I have the three matrices that I need. All I need to do now is work out what each of their determinants are, and then I will substitute them into the formula for Cramer's rule. So I'm going to make some space over here. So remember the determinant of A, how we work it out. We say determinant of A is the product in the leading diagonal minus the product in the minor diagonal. This is an easy way to remember it for 2 by 2 matrix. And for 3 by 3 matrices, there are other ways to do it. It's not just always leading diagonal and then the other diagonal. No, with 3 by 3 and bigger matrices, there's a special way to do it. So here for 2 by 2, we just shorten it so it's easier to understand. Okay, so we would say this is 1 times minus 1, which is minus 1, and then we subtract instead of add. So we subtract the product over there, which is 1. Okay, because it's 1 times 1, which is 1. So I have minus 1 times 1, and this gives me minus 2. Then I have the determinant of AX. The determinant will be 45 times minus 1. This is minus 45. And then I subtract 15 times 1, which is 15. Minus 45 minus 15, that should give me minus 60. Okay, and then the determinant of a y. Okay, so I look at this matrix over here, and then it is major diagonal, which is 15, the product of that, minus leading, minus the product on the leading of the minor diagonal rather, and that is what I have. This is 15 minus 45. Okay, so 15 minus 45, this should be equal to minus 30. Yes, that is right. So this is equal to minus 30. So I have all the determinants that I need. I have a, and then ax, and then minus 30. All I have to do is substitute them into the formula, and then I can work out what x and y are. So just some space over here. Okay, so remember, x, we said, is equal to the determinant of ax divided by the determinant of a. That's right. So the determinant of ax, this is equal to minus 60. And then the determinant of a is minus 2. Minus 60 divided by minus 2, this is equal to positive 30. So x is 30. And then y, we said by Cramer's rule, this is the determinant of ay over the determinant of a, and that is equal to minus 30 divided by the determinant of a, which is minus 2. So minus 30 divided by minus 2, this is equal to positive 15. So here are my two solutions, 30 and 15. So it's always good to check your solutions if they work. From the question, it said that the sum of the two numbers is 45, so I will check. So this is me doing my check. This I would normally just do on my calculator and make sure that it is correct. So I will say x plus y, the sum, so 30 plus 45, this is, sorry, not 30 plus 45, 30 plus 15, because my two numbers, x and y, are 30 and 15. So I have 30 plus 15, this is equal to 45. And then I also check that the difference, 30 minus 15, this is also equal to 15, as we are required to have. Okay, so that is basically how you would solve simultaneous equations using Cramer's rule. So whether the question is given to you in as equations or as a word problem, you can use Cramer's rule to solve simultaneous equations.